Hello, everyone. Welcome to the Google Developer Student Club. My name is Sarah Al-Hadwani, and today we're going to have an introduction about the machine learning. So, first of all, I'm going to show you a video about what is a machine learning, and then I will ask you a question about this video.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it this one's a dog, that one's a cat. A computer program to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Okay, so from the video, how would you define machine learning? You can write in the chat if you know the answer. So anybody knows what machine learning is? Or have an idea about it?
It's like to give some information to programming or something. This is A, and the program will not. This is A, not a B, like that.
Thank you, Zahra. Anyone have other answer? Yeah, Zahra, if you're done, please mute your mic. Thank you. Yeah, it's correct. It's teaching the machine to do tasks that a human do. So like machine learning is a specific field of AI where a system learns to find patterns and example in order to make predictions. Okay, so now we have a small game that we're going to do. So I will share the link with you. You can open it and try it. And try it from your own computer. So that's the link of the game. So it's basically about artificial intelligence and like how the machine learning is used in a growing number of applications, though it's not a replacement for every task. So I'm going to show you this game. Let's start this game. So for example, It says here, Joe Panda.
I see rainbow.
He
Or
said,
smiley face. Oh, I know. It's panda.
so yeah, that's how like he's trying to
I see line.
recognize
Bench.
what you're doing.
Or underwear. Or cannon. No, it's bicycle.
Oh, great. So that's basically. So you can go ahead and try this game now. I will give you like 5 minutes to try the game. So yeah, everyone click on this game and see how it works and how the machine can like guess what you're drawing. When you're done, just write on the chat done so we can go to the other slide. So like guys, in this activity, you'll explore an example of machine learning. So enjoy this activity and see if you can form a hypothesis or evidence-based theory and how it works. We'll use this to develop an understanding of how machine learning works. So yeah, open the internet browser or this link. Yeah, great. I can see some people who already finished the game. Great. Hope you enjoy it. Uh, okay. So anybody of you knows how does the game work? Yeah, no worries. So like how do you think this AI or the machine learning or the platform knows how or what you're drawing? Is it a bicycle or is it a train? Anyone have any answer about it? Yeah, that's true, Safe. Yeah, that's true, Muhammad Riafe. Yeah, that's correct. Uh-huh. So, here is a clue to how the game works. So there is a large amount of data used to teach this game how to recognize the image. So here you can see a lot of examples for an object. So in this slides, there are some examples for a carrot. So if we're going to describe what a carrot was to someone who had never seen one before using only these images, how would they describe it? So how do you think we can describe those carrots like based on their shapes? You can see like some of them have triangle shapes. So what do you think? Yeah, that's true, Hassan. Okay. So you may be already familiar with the traditional programming where you start with a goal, write logical rules, and refine through testing until it works the way you want it to. So imagine if you tried to describe a carrot the way you just described using traditional programming rules, such as those on the right side of the slide. So like saying like if object.height is greater than 10, do X or so on. So this approach would get very complicated, especially if you wanted to account for all of the possible ways one could draw an object. So machine learning is an alternative approach to build software. So instead of programmers creating the rules, a model is trained with examples Rather than trying to define for the computer what a carrot is and account for all of the possibilities, the computer is given lots of varying examples like you saw in the quick draw and told this is a carrot. So like this is a carrot, for example, this is a carrot, this is also a carrot. So like all of them, he tried to recognize all of those drawing as one shape. So I have a question. Yeah, that's true. So what might be a limitation of a machine learning approach? Can any one of you guess? Okay, I'm going to tell you. So like the machine learning model is only good as the examples. Yeah, that's true, Salma. It might mix some data, it might find something similar, and it may hard for it to detect something. So for example, like if all the examples are triangle shaped, it might fail to recognize a rectangular shaped drawing as a carrot. Okay. So now we're going to talk about the approaches that we use. So like, is it, so when we alphabetizing a list of song titles, do you think it's a rule-based approach or machine learning? So rule-based approach mean like traditional programming. So do you think it's a traditional programming or machine learning? And if you know the answer? Say if you're true. No. I mean subnets. I don't know what's your name. Yeah, it's the traditional. Do you know why is it the traditional programming or rule based? Because there are sorting rules algorithms well suited for this task. So there are a fixed number of letters in the alphabet. So there are only so many rules one would need to write. That's why we doesn't need to have machine learning for it. Well done. So when we're ranking a web search results, do you think it's a traditional approach or machine learning?
Traditional?
Why do you think so? Actually, guys, do you know both of them can be correct because the approach you take would depend on your goal. So are you ranking web result based or relevant to my query, or if the query was new? Okay. You might also want to take into account how recently the article was posted. So like we can use both of them. We can use the traditional programming or the machine learning. Okay. Predicting housing prices based on location. What do you think? Yeah, Zahra, that's true. Yeah, Zahra, that's true. It's machine learning. Do you know why? Because there is no perfect formula determining how much a home would cost based on its location. So there are other factors that could play a part in how much a home price costs. You didn't understand. So like, for example, if I want to see like how much this home would cost depend on the location. Like for example, if this home was in the city, would it cost more, for example, if it was in the middle of the city or not? Maybe. So in order to do that, we cannot use a rule-based or the traditional way. We need to use machine learning because we need to consider the environments, for example, the traffic and many other things. Yeah, that's correct, Said. Okay, so processing online payments, what do you think? Like when you want to pay for your bills, do you need a machine learning? Yeah, that's absolutely right. It's rule based. Yeah, because like online payments are a straightforward logical process, it is possible for a programmer to confidently program the exact steps necessarily. So, fraud detection, knowing whether a credit card number was stolen, and using inappropriately is much more complex and hard to define. Machine learning could be used for the specific part for the online payment, but like for the easy thing for the main payments, we usually use the traditional way. The machine doesn't have to be that smart. Okay, classifying an object in a photo, like photo detection. What do you think? And the image recognition? Yeah, absolutely correct. We will use the machine learning because there are too many variables to try and create rules for every situation. So now, no two photos are alike, so even a photo of a famous landmark could be captured at different angle. So sometimes of daylight, this would make it much harder to define what an object is in code. So machine learning builds a representation for many examples like this so it can be more flexible and able to handle this situation. Okay. So we need both of them. So like machine learning will not become the default option for software. It is best suited for a certain situation, but not all. So for the rule-based approach, we use it for rules are defined, improvement come from algorithms and network. In the machine learning, it learns patterns from the data. Improvement can form additional data. So we still need both. So the idea to implementation. So while machine learning offers powerful new opportunities, implementing a machine learning system can be more complex than traditional software. This is primary because a machine learning system is only as good as the data as it is trained on. So in this section, I will provide an overview of the process as well as the important considerations. Here, another video.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses.
Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
So let's talk about the machine learning process. So machine learning begins with the needs of your user and business. So with a mind, you define an object so you know how to proceed. Example could include predict which friends a user is likely to share a photo with, suggest the user should eat in a new city based on the restaurants they have visited in the past. So this goals should achieve success matrices as well. So machine learning models learn from examples, so it is essential to find a large existing source of data that is relevant to your problem. Experts say collecting, cleaning, exploring, and other data processes tend to be the longest but most critical part of the process. So the arrow pointing back from prediction to data shows the iterative nature of machine learning. You will need to refine your model and perhaps your data collection and processing based on the feedback until it is achieving the results you are looking for.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias. Like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
So, humans are prone to trust results from a computer. We assume our technology will work as designed until it breaks. However, even a well-designed machine learning pipeline can experience issues when it picks up on biases found in the data. So, from the video, when someone describes to you a new application of machine learning, what questions would you ask them based on this video? Can anyone write on the chat or answer?
Can you repeat the question?
Yeah, sure. So like when someone described to you a new application of machine learning, what questions would you ask them? Anyone have any idea?
You would ask them if they're sure there isn't any human bias in it, like the video said.
Yeah, that's true. Okay, another question. What approaches could a software development team take to mitigate bias in their machine learning system? Okay, let's see this. Yeah.
Can you repeat that again, please?
Yeah, sure. So, like, what approaches could a software development team take to mitigate bias in their machine learning system? So, what do you think a software developer can make?
Surveys, maybe?
Yeah, that's true. Yeah, collecting data. Okay.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Okay, so the main key points in this video, gather and select only the data that your machine learning system needs to achieve its goal. So the less data you have in the first place, the less you need to protect. This might seem like a common sense, but it takes effort. So it's easier to copy a whole database in your machine learning system than to spend hours removing the parts that you don't need. So strip away data that your model doesn't need. And various laws and company policies regulate how data must be kept private. So a machine learning product needs to be compliant with every country it has customers and users. So let's talk about what can machine learning do. So it's easy to look at examples of machine learning and see it is magical. It does open a lot of new possibilities with technology. We already considered for certain situations whether machine learning was necessary. In this section, we will discuss what type of problems machine learning is best suited for. So, in the news articles and discussions, it's common to hear artificial intelligence, machine learning, and deep learning. So it's used interchangeably, but there are distinguished between them. So artificial intelligence is defined as any technology which appears to do something smart. This can be anything from programmed software to deep learning models, which mimic human intelligence. While the machine learning is a specific kind of artificial intelligence, but rather than a rule-based approach. So the system learns how to do something from examples rather than being explicitly told what to do. In the deep learning, it's a specific type of the machine learning using a technique known as a neural network, which connects multiple models together to solve even more complex type of problems. Deep learning, similar to other machine learning models, learns via examples. It's unique because it connects models to other models in layers in order to handle more complex types of data, like as images. So that brings us to this very simplified overview of history of machine learning. You can find more detailed timelines on Wikipedia and so on, but the main keys takeaway. So the key algorithms powering machine learning were formulated even as much as centuries ago. They come from like statistics, linear algebra, biology, physics. So for the last few decades, sufficiently large amount of data were collected to train models, but they were low quality and expensive to train. Lack of progress on prospect lead to an AI winter, if anyone heard of it. So where machine learning was considered a waste of time in the past. So in the last few decades, the availability of relativity and cheap and fast computing power have enabled the complex calculations across large sets of data necessarily to train highly accurate models. So let's talk about the types of them. The types of the machine learning. The first one is called classification. So classification is a common application of a machine learning. The system determines which class or category an example belongs to. The output can be a label and percentage of confidence. For example, if the classifier was trained to identify whether or not an image was of a lion, it might output yes or no. However, if it was more directly an animal classifier, the output could be lion or tiger. Classification systems depend on the threshold set by human developers, so the system can distinguish between cases that might be less clear. If you built an email spam classifier, it would be necessary to fine-tune the threshold so your system didn't incorrectly label an email as a spam when it was genuine. So the second type is called regression. Regression systems output a number. So, for example, how long it will take to drive from point A to point B, or the likelihood that someone will click on an ad. So regression systems can be as simple as drawing a line as you see above, or complex models depending on multiple variables. And we have clustering is the third type. So another application of machine learning is determining how closely related items are one to another. So in this slide, the data of hand-drawn images is moved into clusters of the same numbers. So like ones with ones, twos with twos. So even within clusters of the same number, the images are further clustered by those which are similar in the shape. For example, some 2 and 7 may look similar. So like the machine can mistake between them. The fourth type is sequence prediction. So in order to assist users, it can be helpful to predict what they might do next. This could be a prediction of the next keyboard key a user will select, as you see in the screenshot. So this could be used to propose a spelling correction or suggest replies to a text message. Other example of sequence prediction could include the next video or a user might want to watch, or a next stop on a vacation, for example. And we have the style transfer. The styles transfer or the generation, it involves training a model on one set of data and then applying that model to something completely different. It could be as seen in this example. So like remarking photographs to look like another piece of art, or translating a voice from male to female, or even another language. Now that you have seen a few examples of the machine learning, let's go through other examples, and you tell me which type of machine learning best describe it. I say best because some problems can be solved by multiple approaches to machine learning. So let's start. If you know the answer, write in the chat. So what type of machine learning do we use when recommending what someone will download based on a previous purchases? What do you think? Yeah, that's correct. It's sequence prediction. Do you know why? While all of those examples of machine learning involve previous examples, This is an example of predicting the next thing a person will do based on a previous or similar sequence the model has learned to. So, like, you know, those ads that pop up suddenly in your screen and they kind of related to the stuff that you bought online. So, like, you bought something from Amazon and suddenly you see an ad or something. Yeah. So, it's a sequence prediction. Okay. So, when labeling email, if it's a spam or not spam, what do you think? Which type do we use? That's correct. It's a classification because when the goal is to output discrete prediction labels like yes, no, or spam, not spam, this is a good fit for a classification system. So, identifying trends amongst a group of people who have bought a new musical release. So, what do you think? Anyone can guess anything? No, it's not. Yeah, correct. It's clustering. Because the goal for this problem is less about making a specific prediction, like the sequence prediction example earlier, but looking for similarities and finding cluster trends grouping based on something in common. So it's cluster. Okay. Captioning a video. What do you think? Yeah, that's correct, Sahara. That's correct, Muhammad. Yeah, it's a style transfer. Because when the type of data generated by the system is different than the input data, this is an example of a style transfer. So like in this example, so the input data may be like a video, image, or frames, is translated into describing what's depicted in the image. Okay, so determining workout activity based on phone movements. What do you think? So you think, yeah, that's correct, Lena. It's classification. Do you know why? Because the goal is to output discrete labels such as walking, running, jumping, which makes this track a good fit for classification. So it's possible this could be determined without machine learning, but there would be so many situations where a person could be working out, but instead driving a car. How would you improve a machine learning system to better understand the difference? Like, if we want, like, for example, to track how many distance did we walk, and for example, we're just sitting in our car and our phone thinks that we are moving. How do you think the machine will knows that you are really walking or you're just in your car?
Include the speed.
Yeah, we may do that. But do you know what we usually do with the machines? Like we ensure our model is trained with lots of examples of driving. So like the technical term in this situation is the false position because we're in the car. So, and we may say like you're okay bicycling. So yeah, we say it's true. So yeah, it's a classification. Okay. When predicting the strength of a password, so like for example, when you log in a website, how does the machine knows if your password is strong or weak? So what type do you think do we use? Sequence prediction? No. Yeah, that's true. We use classification, and yeah, and we also can use regression, because when the output of a machine learning system is a continuous number, such as your password is 50% stronger than others, it is a regression problem. However, your users might prefer you take that output and simply classify the output as weak or strong. So both can work, classification or regression. Okay. Identifying famous landmarks in a photo. Yeah, that's correct, Ahmed. It's a classification. Because like when the output is a discrete label such as Burj Khalifa or Eiffel Tower or the Great Wall of China, it's a classification problem. Okay. When suggesting spelling corrections, when we do the autocorrect thing, so what do you think, what type do we use? No. Not really. No, not regression. No, that's not. Yeah, that's correct. We use clustering. Do you know why? Because clustering is a useful approach for this problem because misspelled words tend to be closer to the intended word. So, like, for example, when we say in English avocado and in French, we say avocate. So, like, they are similar when you in the spelling and this and how the way you write them. So this word would be close together as well. So it is possible to build a spelling checker using traditional approaches, but they would be complex, of lower quality, and need to be adapted to fit new words and slangs. So we need clustering for this one. Okay. Predicting the quality score for the advertisement. What do you think? Yeah, that's correct, Muhammad. Yeah, it's regression. Can you tell us why? Anyone can tell us why it is regression? Okay, you don't know how to explain. So the output of the machine learning system is a continuous numerical score, like such as a 3 out of 10 or like 97.2%. So this score would probably be based on numerous features. That's why we need to use regression. Yeah, sure. Let's go back to the regression slides.
If you can let me comment on this, Sarah.
Yeah.
Regression is very simple thing. It's like we call it binary regression. You have two things. Either this thing is this or not. It's yes or no. So if you have a sample of data, and based on this data, you can decide whether it is, for example, is this a lion or not? That's it. When you combine multiple regression together, you can classify different things. Is it a lion? No. Is it a cat? No, and so on. So normally, regression, I will call binary regression. It's either yes or no. Is this thing what is supposed to be, what I have trained my data on? If yes, it gives you a high score. If no, it will give you a low score. And then you have to decide up to what threshold should you consider it yes or no. It's the basic and the most simplest thing. And normally it looks like a line because you can separate the data that anything over the line is, for example, yes, anything under the line is no. So it's linear. When the data becomes complicated, you have different data and you have to draw it as a curve. In this case, now becomes non-linear problem. It cannot become like a regression or become very hard to predict because you need to optimize it because it's not a line, a simple line that you can separate the data into two different groups. Thank you.
Thank you for your information. So we're done with it. So if anyone have any question? Great. So guys, by the way, tomorrow we will start our first technical session. So like all of you need to have their free subscription on a Quick Labs because you will start using it from tomorrow. So anyone still didn't get his free monthly subscription or have an issue with it? Great. So like if everything is good, thank you everyone. You may leave. Thank you, Asim.
Thank you.